Hey guys, welcome to part two of your Quadrilaterals study guide for the test on Monday. I will have a few minutes on Monday if there's any last minute questions you have for live action Roden, but hopefully this video can help you kind of get ready for the test. And if you have any questions, just don't freak out on me. On Monday. Excuse me, I'll have a little question session. So just let me know what I can do on Monday. Okay. All right. There was a mistake on page three. What is it? 340 with number 27. I put in the wrong number. So if you have a question on that, I can also take that. Most of you guys said that you didn't have a question, but if you change your mind, let me know on Monday. We can go over it. All right. Let's get right down to it. Let's finish up part two here. All right. So now we left off, I believe, on page, I think we left on page 360, number 10. Okay, so let's go ahead and do number 10. Now, I believe they tell us that this is a parallelogram, if I remember number 10. I don't have the book in front of me. So let me, 1 second. I'm going to pause this really quick and pull my phone up so I can see the directions. So let me do this. Sorry, I'm going to go here, and I'm going to pause the video. So yeah, I took pictures of these on my phone here because I don't have a book, but it does say that this is a parallelogram. So this is given that it is a parallelogram. Okay, so if it's a parallelogram, then the diagonals bisect each other, right? So it looks like we don't want to use this and this yet because you have an X and a Y. So that's not the pair that I want to probably compare to each other. But since they're just both X's and these two, we can say that those two blue equations are equal to each other because the diagonals of a parallelogram bisect each other. So we can figure out X by having the equation 4X minus 4 equals 3X plus 2. And then we'll just subtract 3x from both sides. So that gives me x minus 4 equals 2. And then we'll add 4 to both sides. And so we get x equals 6, if I did my math right. All right, so now once we know that x equals 6, we can plug that x value into this yellow equation x. So we can say that 2y plus 2 equals 2 times 6, which is 12. Because x is 6, and the yellow ones bisect each other also. And then we can just subtract 2 from both sides. So we get 2y equals 10. Divide both sides by 5. Divide both sides by 2 and get y equals 5. So our two solutions are x equals 6 and y equals 5. Okay, so this one on this, let me just check this one. So they do say that this is a parallelogram. So how could we do this one? So this is a rectangle, okay? And why do I know it's a rectangle? Because it's a parallelogram, and that's given on number 11. So we could say, well, the opposite angles are congruent, so we know that's a right angle. And then there's a lot of different things you could say. These are same side interior angles, or they have to be the same. So it's interesting that when you have a parallelogram, you only really need to put one right angle in there, and you can deduce that the rest of them are right angles, okay? Now, remember, we don't know that the diagonals bisect the angles, so we can't just automatically start saying that other things are equal to 36 or anything like that. But one thing I do know, since I have a parallelogram, I do have I have a transversal and I have alternate interior angles. So right off the bat, I can say that x is equal to 36 degrees because it is the alternate interior angle to 36 degrees. See that? And since it's a parallelogram, I know those lines are parallel. So right off the bat, I can say that x equals 36 degrees. Okay? Get rid of that. All right, so now that I know that x equals 36 degrees, what can I do here? Let's see here. So, well, in this case, let's see here. So, diagonals of a rectangle are congruent, And so the diagonals bisect each other because it's a parallelogram. So what I can say is all of these angles are congruent. All these sides are congruent, okay? All these pieces of the diagonals are congruent because it's a rectangle and its diagonals are congruent and they bisect each other, so all the parts have to be congruent. Well, why does that help me here? Well, that helps me because I can now say that if this is 36 degrees, this is also 36 degrees, okay? If this is 36 degrees up here, this is 36 degrees. Now, why can I say that? Because all of these are isosceles triangles, and the base angles of an isosceles triangle are congruent. So I can use the isosceles triangle theorem. So we've got a base angle here and a base angle here. So I can find y very easily just by saying 36 plus 36. Let me just highlight because they're isosceles triangles. So this is 36 and this is 36. Plus y is going to give me 180 because there's always 180 degrees in a triangle. So 36, sorry, I keep hitting the wrong thing here. 36 plus y equals 180. And so I can do the math here. Let me get my calculator out so I don't make a stupid mistake online. So 36 times 2 is 72. So this is 72 plus y equals 180. And then you can take 180 and you can subtract 72 and you get 108. So y equals 108. Okay? Now, once you know y equals 108, z and y they're not equal to each other, but they are supplementary, right? Because they make a straight line. So if you take 108, if you take 180 degrees, 180, and you subtract 108 from that, you'll get the measure of angle z, which is 72. So z will be 72. So z is 72. And the reason I got that is because y and z are supplementary. They form a straight line. They're what we call a linear pair. So if y is 108 and there's 180 degrees in a straight line, 180 minus 108 is 72. And we're done. All right, next problem. The next problem is, what do they say on 360 number 17? Let me just make sure I'm not taking a look at my picture on my phone. 360 number 17. Determine whether the values of the variables, values of the variables for A, B, C, D is a parallelogram. Okay, so again, parallelogram. Opposite sides of a parallelogram are congruent. So we can write two equations. We can say that 7x minus 1 is equal to 6x plus y. Now, we cannot say that 7x minus 1 is equal to 5x plus 2. It may be, it may not be, but we don't know if this is a rhombus or not. We're not told if it's a rhombus. We don't have enough information here to know it's a rhombus. So we cannot say 7x minus 2 equals 6x plus y because we don't know it's a rhombus. It may be a rhombus, we may not be a rhombus. We'll see if here it is here in a minute. Okay? So the other equation I can write is 7x minus 2 equals 5x plus 2 because we know it's a parallelogram and opposite sides are congruent. Now, I can't use this one right here because it has an x and a y in it. See, there's an x and there's a y. So you can't solve one equation with two variables. But this one is good because it has only x. So what we can do now is, so if we have 7x minus 2 equals 5x plus 2, I can start to solve for x. So we can subtract 5x's from both sides. So 7x minus 5x gives me 2x minus 2 equals 2. And then I can add 2 to both sides. So 2x equals 4. And then we can divide by 2. So back to x equals 2. Okay. So now that I know that x equals 2, I can plug it into this equation right here because now I know that x equals 2. So I have 7 times 2 minus 1 equals 6 times 2 plus y. Okay, well, 7 times 2 is 14, so 14 minus 1 equals 12 plus y. And then 14 minus 1 is 13, so 13 equals 12 plus y. We'll subtract 12 from both sides, and I believe we get y equals 1. And we're done. All right, next problem. We're on 360, number 18. And we want to find the measure of angle 1 and angle 2. Okay? All right, so let's go ahead and take a look at that problem. All right, so it's a kite, and I know it's a kite because it has two pairs of congruent adjacent sides, and the opposite sides are not congruent. All right, so how can I find measure of angle 1? The measure of angle 1 is 90 degrees because we know that diagonals on a kite are perpendicular. So I can say the measure of angle 1 equals 90 degrees. All right, so now I also know that this angle, let's see here, this angle right here is 60 because the diagonal of a kite bisects the non-congruent angles. So this angle right here, I'll highlight it, this angle right here, and this angle right here are non-congruent angles, okay? They're not, one's an acute and one's an obtuse, or maybe a 90, who knows? So it's definitely not, it's definitely an obtuse. So this entire green angle here is being bisected by this diagonal. So if it's 60 on here, it's 60 over here, okay? So with that being said, we also know that this has to be 90 because these are all 90s, right? So our equation is 90 plus 60 plus x, which is angle 2, equals 180 degrees because it's a triangle. Well, 90 plus 60 is 150 plus x equals 180 degrees. And then I'm simply just going to subtract 150 from both sides. And I think I can do the math in my head and get 30. So we know the measure of angle 2 equals 30 degrees. And we're done. All right, so I think that's it for that. I don't know if there was another way we could do that, but I think we got both of those answers right there. All right, let's take a look at the last one. The last one is page 360, number 23. It says that we want to prove in this case that the diagonals are congruent. AC is congruent to BD. And it's telling us that it's a square, right? So a square obviously is a rhombotangle, and so which means it has rhombus and square traits. So let's see here. So if we wanted to prove that AC is BD, then we can just use the distance formula, okay? Now remember, guys, the coordinates of A are 0, 0. Okay, so the distance formula says that we have x1 plus x1 minus x2 squared plus y1 minus y2 squared, square root of that whole thing. All right, so here we go. So we have the square root of, okay, so let's call this x1, y1, and x2, y2, okay? So we have 0 minus a squared plus, what do we have? 0 minus a squared again. So if we have 0 minus a squared is negative a squared. So this is just going to be a squared plus a squared. So this is going to be 2a squared So when we simplify this, and like what we did in class on yesterday, when or today, we have this could be the square root of 2 times the square root of a squared, and the square root of a squared is what we learned. Remember, to break out of square root jail, you take half and break out. So this is going to be a times the square root of 2. Okay, so let's show that BD is also a times the square root of 2. So here we go. So this is going to be distance equals, and I'm going to just say this is x1, y1, and this is x2, y2. All right, let's put that in. So it's going to be xa minus 0 squared plus 0 minus a squared. Okay? And then do the math here. We're going to get a minus 0 is a squared. We get a squared. 0 minus a is negative a squared. We get a squared. We get a squared. We get 2 square root of 2a squared, which gives me a times the square root of 2. So they are equal to each other. All right, guys, hopefully this video was helpful and you guys are ready for your test. Finish up your simplifying square roots or simplifying radicals or simplifying square roots is your delta math. And we'll see you guys on Monday for the test. Have a great day. See you later. Bye.